Listening to the presentation so far, I think I have recognizable subjects for you in this presentation that deals about the project that we started recently in September to think about updates of the Q10 and the other Q dummies, but focused on the Q10 to address the feedback that we got from users and stakeholders in the recent evaluation time and use time. So our project will not come to a product earlier, we think, than 2018. The prototypes will be earlier, but then we have third-party evaluations as normal. The Q dummies are introduced in NCAP consumer testing in regulations and also at ADAC in the consumer testing done there. And based on experience gained so far, there are three main areas of concern or potential improvement. Those areas are the shoulder belt interaction with the chest and submarining, abdominal loading and side impact performance. So we started a project in September, and the next few slides will give you an impression on what the ideas are and how we think we can solve it. So a current status, nothing is fixed. We are open for ideas, so if you want to tell us something, please contact us. A lot of papers were published in the last few years on mainly the Q10 dummy. So we want to have a sort of advisory group installed, and we approached already some stakeholders to get that set up, and we communicated to get their feedback. And we will have 1 or 2 times a year a meeting with them, a WebEx or a physical meeting. The shoulder belt interaction, it's brought up by a lot of parties, as you can see here, NCAP, GRSP, EVC Working Group 12, and some users that come up with some feedback in the papers mentioned. What are possible design change options to get that better represented in the dummy? We could make the dummy less elliptical, more square, thoracic shape. We could better represent soft tissue that could give the belt a sort of biting performance in the flesh. We can reduce the rib stiffness at the sternum, just to represent cartilage that is in the human there. And you can consider the shape and the position of the shoulder. The submarining, we have heard about that already in some presentations. One major thing I will expand upon is that we can have a change of the pelvis position relative to the torso, so a slouched position. But probably is also nice to know that we developed for the Q6 and the Q10 a ACES load cell, which is pictured here. We don't want to end up with a large omnidirectional child dummy that is developed in America. We don't want to have such a complex design, which is more like Thor and WorldSit than a Q dummy design. But probably we can learn from that. Then for lateral impact, we can improve several items, and mass distribution is one of the major things, I think. So try to put as much mass in soft parts of the dummy, maybe the soot even, rather than in the metal parts like thoracic spine and such parts. Well, this is our design cycle, so let's start with ideas. We confront them with requirements, and we would like to try and use our FEM model to compare if we are going in the right direction. We will do an analysis, a trade-off study, and we will come up with selected concepts. This will result probably in the availability of a FEM model of this dummy years before the prototype is available, and that's quite new. So probably the evaluation of the updated Q10 could be started at third parties before the hardware is available. These are prototypes that are already available or being produced now, especially the ACES load cell in the Q10 and the Q6. Also, this is available, the string potentiometer. And on all Q dummies, we have now an integration of the abdomen sensors. Then the main thing is posture. We have defined the Q dummies so far in an erected position, whereas in the car, the children are not sitting like that. And we have contacted Matt Reed of UMTRI to develop for us a Q10 and a Q6 compatible posture representation. This is the posture representation which was used for the large omnidirectional dummy a few years ago, but it is not compatible with Q10 with regards to shoulder height and that sort of things. So they will come up with an updated one. And I will project the dummy over it. Here you see the current Q dummy, Q10 dummy, which you can see is erected and does not comply with the posture of this representation. So more slouching is necessary, and the shoulder joint should be shifted forward, and so on. Here you see the Q10 model modified for this posture. This is in overlay two dummies, so the erected and the slouched Q10, and we shifted the neck 25 millimeters forward. We rotated the neck nose up by 5 degrees. We shifted the shoulder forward to match with this posture representation by 35 millimeters, and a lot of repercussions in the dummy. So clavicles and shoulder rubbers and so on should be adapted to that. Then we can introduce flexible elements like on the directional child dummy at T5 and T10 without jeopardizing the integral ribcage concept of the Q dummies. And then the slouched position is introduced at T12 L1 by 25 degrees, and this is for a booster seat configuration. For the configuration sitting on the bench directly, the slouching will probably be more than that, Matt Reed indicated. You see here that the 8-point shift is about 73 millimeters forward for this amount of slouching. And we will have probably a sternum cartilage representation. The floating ribs and the false ribs will be cut off the rib cage and being attributed to the abdomen area, and the mass of the jacket will probably increase to get as much mass in the soft parts. This will help us also for side impact. This is in summary that we need a balance between ease of use that we have now in the Q dummies and biomechanical excellence. So we hope to have the advisory group wise enough to make a trade-off between those two ends of the scale. Thank you very much for your attention.